Well, welcome back, folks. Today's episode is going to be a fabrication project. What you see in the shot right now is an aftermarket plug or cap that I bought from my Honda SL70. These were used on some of the Japanese Enduros. I don't know if they were used on street bikes, and I don't think they were used at all on probably dirt bikes, true dirt bikes. But this plug or cap was used to fill the unused threaded hole in the handlebar mount for the rear view mirror. And either one side or the other, depending on your country and which side of the road you typically drive on, the unused side just had that threaded hole, and they capped it with this little plastic plug. Now, to my knowledge, these are no longer available from the OEMs, and I know Kawasaki used them, Honda used them. I'm not sure whether Suzuki and Yamaha did. They might have. I've never recall coming across them on Suzuki or Yamaha's, but they might have used them. But I've never been able to find one. Well, you can probably find them NOS if you can even find a part number. Sometimes they don't even list a part number for this item. Again, this is a reproduction from I took off of my Honda SL70 project. I bought it aftermarket. I have not been able to find them back. I think I got this part originally from Marbles Motors, but I couldn't swear to it anymore because, again, I can't find them. So this project is going to entail fabricating or machining a new version of this for my bikes. My Kawasaki G5 100 has always needed one of these, and I never got around to making one for it. Again, this came off the Honda SL70. And I'm going to make a few extras while I'm at it, while I've got the setup going and the machine is set up, the lathe. And while I'm going to make the mess of it, I just make a few extras. I'm going to make this from Delrin. See right here, this is just a piece of, this was originally 12 inches long by 1 inch in diameter, 25 millimeters. You can buy Delrin, and it's readily available. It's a very free machining. It's a very hard, free machining, modern engineering plastic. It's used all over in industry, readily available, not very expensive. I found it in all different diameters, usually in 1/4 inch imperial increments, 1/2 inch, 3/4, 1 inch, 1 1/4 inch, 1.5 inch, etc. I happen to buy 1 inch. I wanted it, even though this is way too large for my project, as you can see there. I wanted some left over. In other words, when I was done, I knew I wasn't going to use all of this up for this project, and I wanted to have something a little bit larger than like 3/4 inch, for instance. I could have used that and had less waste. I realized that, but I wanted to have some left over that was more flexible in the future if I had other projects I wish to use this for. So even though I'll have a little waste because of it, I want to start with something a little bit larger, and we're going to machine this down. So it's a great material for this, and again, readily available. This original part, this aftermarket part, was cast. This is not a machine piece, and I can just tell by looking at it. I don't know if you can see that there. This little stub right here, it was made in a mold, very likely, and it's not Delrin, I don't think. It's probably some kind of a plastic, polyethylene or something like that. I don't know for sure. And it's a little bit more translucent than this material, which is pure white, which I guess I don't really care about in this application. I think this will work fine, even though it's a little whiter. Now, I have already gone ahead and made two. I had to experiment a little bit with my setup, and here's the two that I made right there. There's the original, my right hand. These are the two on the left. I'm going to make two more. Like I said, I'm going to have some spares around that type of thing. But it was very easy to machine. I got the process down to like 20 minutes. I can make one of these in like 20 minutes now on my lathe, and this will be a pure lathe project. It will be machined. I did make a working drawing, like you can see here. Let me see if I can get that in a shot for you. You can see I dimensioned it in both metric and imperial. Now I would prefer to work in all metric if I could. And these dimensions, by the way, I took directly off of that part right there, the one I pulled off my SL70. So I measured it with my trusty little caliper here and dimensioned it out so that I have a working drawing. Now the reason I have both metric and imperial dimensions on here is my lathe and my dial indicators that I will use to set up the lathe when we get over there work only in imperial. I don't have any metric dial indicators, and the lathe itself is an older American made lathe, purely imperial. So I put both dimensions on here just to make it easier for me to reference while I'm working on the part. And this is an over dimension drawing. In other words, I don't need all of these dimensions. I could surmise or calculate some of the dimensions from some of the others. I could have made it simpler, but for the sake of this exercise, it doesn't make any difference. But just be aware, I know it's over dimensioned, but that's, for my purposes, it'll work fine. Most of these dimensions aren't critical at all. The most critical was going to be this diameter right here. That's the diameter of this shank, or the stem, where it pushes down into the threaded section of the handlebar mount. So this dimension, which is about 8.9 millimeters, 0.350 imperial, is really the only one that's you have to be reasonably close on. The rest of these, as long as you're in the ballpark visually and it looks right, I think you're going to be good to go. I'm going to be good to go. So I will get as close to these as I can, of course, but I am in particular going to pay attention to this diameter right here, because that does have to have a fit to the internal threaded section on the handlebar mount. And speaking of the handlebar mount, let's go over to the little Honda, and I'll just, if some of you aren't able to visualize what I'm talking about, we'll take a look at it at the bike, and you'll see exactly what I'm talking about. Little Honda SL70, you can see here in the front brake mount. I do not have mirrors on this bike, by the way, on either side, so I have two of these. You can see this one I would put in when I restored the bike a few years ago and has never been removed, so that's the right mount. The one in my hand, the one I removed and used as a model, came out of the left side. And on the left clutch perch mount, you can see the little threaded hole where I removed this part as my model. And this just is a force fit. It's a friction fit, and you just push it in. And I very carefully used a real thin bladed putty knife with a tape around it. I put tape on it first so I didn't mar this part. You know, I didn't want to damage this, because I'm going to put it back, but it just fit, you know, push it in with your thumb, and it's a nice friction fit, but you can remove them if you need to, if you're careful with it. So that's the application that we're going to be fabricating today. One of these, or actually several of these little plastic plugs, and we're going to go over here now to the lathe and get set up, and I'll explain to you a little bit my setup and how we're going to do it. Let me explain the setup I have going over here at the lathe. You just saw the facing operation. Facing is the squaring up or cleaning up of this face here. And that's a real simple process. You just clean it up with a tool. I did have the part inserted into the chuck a little bit further for the facing operation because I could. I cut two 7/8 inch long blanks. That's what these are. This one's in the chuck, of course, and here's the second one for each part. I have to allow enough to grab a hold of and hold the part in the chuck. That's why I have to cut them longer than what I need. Otherwise, you have no way of holding the part. And as I indicated earlier, I know I'm going to remove a lot of material and have a lot of waste here, but it's really going to be inevitable for what I'm trying to achieve. In order to machine this part, let me explain what's going to happen here. See if I can get this drawing in such a way that it doesn't have too much glare. This part really is going to be machined in this orientation. I just turned this upside down, as you can see. What I need to do, or what I'm going to do, is machine this dimension right here. That's the 15.2 millimeters, this overall width here, I'm going to machine, take that, this blank right here, I'm going to bring that down like this for this entire length of 13 millimeters. So let me turn around, make it a little easier for you to read. So I'm going to machine this diameter, this distance. I actually have it extended here in the chuck out about 14 millimeter, and that actually closer to 15 to allow a space for the tool to get in there and do its thing. I am using high-speed steel, sharp high-speed steel tooling here. Carbide is not necessary. In fact, carbide is usually not recommended for machining Delrin, but this high-speed steel is just perfect for this type of work. So we're going to bring this down to 15.2 millimeters, this entire distance here, which is 13 millimeters plus. I will get as close as I can to this 15.2 within reason. And the 13 again is not terribly critical because I can always shorten it. If anything, I'm going to leave it, like I said, just a little bit long. I have to, just to allow my tool to get in there. Then what I'm going to do is machine this critical dimension. That's that 8.9.350 imperial. This dimension right here I'm going to machine. And again, remember, this is in the chuck upside down like this. So I'm going to leave it, the setup alone once I've got this size, and then I'm going to come in and I'm going to reduce the size, this step even further, to bring it down to this approximate 8.9 millimeter dimension. That's, again, the primary and critical dimension I want to hold. Then it's just a matter of turning the part around in the chuck so that this part then faces to the right. So it'll be then mounted like this. And I will clamp down on this section here using some soft jaws. They're just copper, pieces of copper pipe. I made some soft jaws years ago for soft materials. I don't want to mar the plastic. So I'll clamp down here, and then remember this dimension's already machined. Then I'll come in and part it off or cut it off right here, and basically I'm done. And like I said, I can get this done in 15-20 minutes without interruption once I start going. So that's the steps I'm going to proceed through. Now I'm not going to show you the entire process, and I'm not going to record 15 or 20 minutes of me just making pass after pass, reducing dimensions or size to get to dimension. It'd be kind of boring, but I will give you a flavor as I progress through this work, the steps that I'm going through so you can see it firsthand. One other thing I want to mention is I know this part's extended quite a bit in the chuck, and if this was metal, especially steel, I wouldn't extend the work this far from the chuck jaws, at least not without having a center here coming in from the end to hold this. But again, I had to hit that compromise between wasting plastic. The headstock here in this lathe will not allow a 1-inch part to pass through. That 1-inch stock, it won't fit. So I had to cut it off anyway. I think that's a 7/8 or 3/4 inch headstock hole in the middle there. I think it's 7/8. Anyway, I had to cut it off anyway, and I didn't want to waste any more than absolutely necessary. So with plastic, such as this Delrin, and I've got this clamp very tight, and remember, much of this, or all of this, is going to be waste anyway. I got it clamped really tight, and I can get away with machining plastic with that kind of an extension, but again, metal, I wouldn't attempt to do it because the chances are the part would get pulled out of the jaws and screwed. go ahead and measure this. We should be real close. .25, 15.26. 15.2 was our target, so I'm going to just leave it at that. I think we're close enough. I'm concerned if I go any, try to refine that any further, it's going to create a problem. And again, we're very, very close right now. So we've got that major diameter done. Now what I'm going to do is I've got to reset my carriage stop. I don't think I talked about that before, but I have a carriage stop right over here that I'm going to move in, and we're going to continue to refine this diameter down further. Let me see if I can't get all of the original pieces here. It's sitting like this right now, so what I'm going to do is leave it in the chuck because we've got this diameter done. And now we're going to come in and reduce this down, but I've got to stop the carriage back here so that I can leave this 3+ millimeter piece right here without machining that off. So I'll do a little setup and I'll bring you back. So I've reset up the lathe. I've reset my carriage stop to create that 3 millimeter wide step. That's this step right here. You can see here it's 3 millimeters, 118 thousandths of an inch. So we're going to create that next right here. And I use my dial indicator down here. I don't know if you can see that or not. That's an imperial dial indicator. So I measured from that previous setup back 118 thousandths of an inch on my dial indicator, fix my carriage stop, and that will create this 3 millimeter step. And I have to bring the diameter down to about 8.9 millimeters. Just to reiterate, this is the most critical dimension right here of all of them, even though none of them are what I'd call terribly critical, given the nature of the part and its usage. But this is the one of all of them that I want to get the closest. The target is 8.9 millimeter, so I have my calculator, there you go, zeroed out at 0 on a metric scale. If you can see that, 8.84. So that's about as close as we're going to get. 8.9 was the goal, so I'm happy with that. Now what we're going to do is I have to turn the part 180 degrees. I'll clamp it here on the stem we just machined, and I think you can see the part now starting to take shape. And then we're going to end up parting it off, or cutting it off, and freeing the part up, and we're 90% of the way done. Got the part reversed. I got a cutoff tool in the tool post holder. You'll see I've got the copper jaws installed. Those are softer, and I've got it clamped down very firmly on that stem that we just machined. I've now moved the tool, this cutoff tool, off 3 millimeter, maybe just a fuzz more, 3+ millimeter, because now I need to create this piece right here. So it's held like this, and what we're going to do now is we're going to cut this off like that with this cutoff tool. Normally using a cutoff tool, especially in steel, is very stressful on the equipment. With this Delrin, it's very easy to do. It's not stressful at all. But when you're cutting heavy steel, hard steel, parting, it's actually called parting off to be more specific. Parting off, a lot of guys don't like doing parting off because it can be a little bit dangerous. It can be hard on the equipment, and some people just take their part over to a bandsaw or the hacksaw and cut it off rather than part it off. But Soft metals, I don't mind parting off in soft metals, brass, aluminum, certainly Delrin is very easy to do. I have parted off in steel before, but again, you've got to be real deliberate when you're setting up to do parting off. So I think I've got everything all set. I've got the carriage lock. That's the carriage that the tool post moves back and forth on like this. Laterally, I've got that locked so that it can't do this kind of a thing on me. So we'll go ahead now and part this tool off. Go ahead and take the part out of the chuck. And there it is. For all practical purposes, that part is done. Let's check this dimension here. I'm just curious how that came out. Again, remember our target here is approximately 3 millimeters. Or about 2.92. Just a fuzz under. Again, that's not critical by any stretch. But it's pretty well done. So what I'll do now is I will just soften the edges here a little bit. And just to clean it up a little bit, we'll go back over the bench. And we'll take back over at the bench. Here's the part we just made. I just softened the edges a little bit. I put them back in the chuck and just brought it up to medium speed. Took a little 1000 grit sandpaper and just broke this edge right here and polished this face. And of course, here's the original. The only dimension I think that we did not check is the overall length. That's approximately 13 millimeters right here. So we'll check that right now. Throw out our caliper. And again, this is not particularly critical, but we're at 13.6 millimeters, so we're real close. And all of these came out real close. So I've got 3 of the 4 done that I'm going to make. It took me probably an hour maybe with messing around and setting up the camera and moving it around and doing the video work. It took me probably an hour or so. Again, I can do this in 20 minutes or less if I have no distractions. So I'm going to go ahead and make one more, and then I got a set of 4, and I'll have a couple of spares. I'm going to put one on the Suzuki TS185, I think, even though I'm not sure Suzuki used those. One on the Kawasaki G5-100. Kawasaki did use something very similar to this, which I again have not been able to find. And I'll have a couple spares. So that's going to be it for this video today, folks. I hope you found it of interest, a little fabrication project. Any issues, questions, thoughts, drop me a note. Otherwise, as usual, thanks for watching.